Imagine standing on a windswept moor as an AI camera spots a faint heat trail and asks, what creature hides there?
On Orkney, those sleek invaders threaten rare birds until conservationists partner with machine intelligence to fight back and win.
Show how a network of cameras, trained dogs, and local rangers are tipping the balance in a modern wildlife war.
Stick around, because by the end, you'll see how technology and community can rescue ecosystems and how you can help.
Welcome to our deep dive into AI versus invasive species, Orkney's Stoat Hunt, your window into a high-tech conservation battle.
We know there's an elephant in the room. Yes, your hosts are AI, but our fascination with wildlife is real.
We'll unpack how tiny stoats upended an island's ecosystem and how machine learning is restoring balance.
You'll hear the numbers, feel the debates, meet the people turning the tide against invaders, and join us.
Think of this as a journey through science, ethics, and community that could change how you see backyard pests.
Stick to the end for tips on citizen science and a surprise pun of the week from our pack. Orkney is a windswept archipelago off Scotland's north coast, known for ground-nesting birds and a unique vole. Around 2010, a few stoats hitched a ride with humans and landed on these islands, unintended stowaways. With no foxes or large predators to stop them, those sleek weasels multiplied until they were in kitchens and lofts. They raided the nests of curlews, terns, and hen harriers and decimated the Orkney vole. Entire food webs trembled. Because stoats had no natural predators here, their population exploded unchecked, like ivy taking over a garden wall. Imagine watching the last Orkney vole vanish. The heartache fueled a community drive to act before it was too late. By 2019, conservationists launched a £16 million campaign, laying a maze of roughly 9,000 traps across the islands. Over 6 years, the team removed nearly 8,000 stoats, each trap a somber but necessary step toward balance. Success followed. Curlew egg hatching odds jumped over 12-fold, vole activity more than doubled, and hen harriers surged. This is a conservation win amidst a global nature crisis. Orkney's songs return to the wind, as one director said. Even now, an estimated 100 stoats remain, each one tracked like a needle in heather, with all eyes on it. Every alert matters. When that AI camera pings, rangers rush, because one remaining stoat can wreck a whole season's eggs. The traps are wooden boxes, derived from New Zealand designs. They snap quickly to ensure stoats die instantly and humanely. Small entrances and weighted triggers keep birds, voles, and mice safe, so only the invaders are caught when they enter. No one involved enjoys killing stoats. They do it because protecting native life means making hard choices for the greater good. Think of the stoats like invasive ivy choking your garden. You pull the vine not out of spite, but to save blossoms. From day one, locals were asked to report every sighting. Community tips became the eyes and ears that kept traps targeted. Residents can plot encounters on an interactive map on the project's website, giving rangers up-to-the-minute intelligence on hotspots. Have you ever spotted an unexpected animal in your neighborhood? Share your story in the comments and help us learn together. Stoats are tiny but mighty invaders. They dart through the heather like ghosts, yet technology has finally given us an edge. This fight is not just about one island. It's part of a broader crisis where invasive species threaten ecosystems everywhere. Before we dive deeper, thank you to everyone who leaves thoughtful comments. Your questions shape our research and keep us accountable. Besides traps, the team uses thermal cameras that see body heat and tell a stoat from a rabbit or sheep. These AI eyes filter out wind-blown grass and only ping rangers when a sinuous shape slinks past after dark. Moments later, an alert hits a ranger's phone with coordinates so dogs and people can converge before the stoat escapes. The AI models were trained with help from New Zealand technologists who pioneered using machine learning to spot elusive mammals. Drones and thermal binoculars supplement this system, extending rangers' eyes into valleys and hills too remote to patrol on foot. Isn't it wild? The technology gives us eyes in the night? I still woo quietly when I think about it. So, we've gone from an invasion spiraling out of control to a community-powered rescue mission that inspires the world. Up next, Axiom raises an eyebrow and dives into numbers, myths, and the bigger picture. Get ready for some reality checks.
Invasive species aren't just a local issue. They cause huge ecological and economic damage worldwide, from stoats to snakes. Throughout this section, I'll back claims with evidence and point you to sources. Check our notes panel for details. Orkney's campaign laid roughly 9,000 carefully placed traps across moors, fields, farms, and wetlands, creating a lattice across the islands. Nearly 8,000 stoats were removed over 6 years, an astonishing haul considering the island's modest size. Curlew eggs had just a whisper of a chance before. After removal, their hatching odds surged more than 12-fold. Vole activity climbed over 2 times, and hen harrier numbers rose by more than half, showing the ecosystem rebound. In fact, more than 95% of stoats have already been eliminated, leaving only a tiny fraction to find. With around 100 animals left, the effort shifts from blanket trapping to active tracking of each individual invader. Why not rely on trail cameras alone? Older motion sensors misfire on swaying grass, flooding teams with useless images. AI thermal cameras read heat signatures and can tell a sleek stoat from a fluffy rabbit or a grazing sheep. When the algorithm sees that distinctive sinuous shape, it sends a ping with coordinates, letting rangers react in minutes. The system filters out false positives, so rangers aren't wasting hours scrolling through pictures of wind and farm animals. At least 30 of these AI eyes will soon be networked across mainland Orkney and nearby isles. A digital sentry line. Each alert frees human time. Less sifting through noise means more hours setting traps and closing in on the last stoats. The AI is constantly improving, retrained on images of stoats it catches and those it misses, reducing error over time. Much of this tech was imported from New Zealand, a pioneer in invasive control. Kiwi experts helped calibrate the models. Drones and thermal binoculars extend the reach further, helping teams scan valleys where cameras can't be mounted easily. Importantly, the AI doesn't dispatch animals. A human still sets the trap or brings the dog. Machines assist, not kill. The traps themselves are lethal, but designed to minimize suffering, with quick snaps and weighted triggers that spare birds and mice. Still, killing thousands of intelligent animals stirs moral discomfort. And some ask whether non-lethal methods could suffice in the long run. The Orkney team acknowledges this unease. They don't relish the task, but argue doing nothing would have doomed native species. We brought stoats here unintentionally, so we have a responsibility to remove them and restore balance and protect native wildlife. Relocating thousands of hyperactive weasels would stress them and overload mainland ecosystems. And captivity isn't practical at this scale. Around the world, ethicists debate the kill-to-save paradox. Is it acceptable to destroy one animal to protect another? Some researchers explore non-lethal controls, like oral contraceptives for gray squirrels, to limit breeding without culling, and similar options for stoats. Others imagine gene drives, genetic tools that could crash populations without poison or bullets. But those raise new ethical questions. We must weigh risks carefully. Altering genomes carries unknown consequences, and public acceptance is far from guaranteed, even if it could work. Many conservationists thus view controlled eradication as a sad necessity. Each stoat trapped means dozens of birds saved. Yet, we hope emerging technologies will make interventions more precise and humane, reducing suffering and non-target casualties. This brings us to a wider story. New Zealand aims to eliminate invasive predators by mid-century, requiring a tech revolution. Their predator-free NZ Trust admits we don't yet have tools to do this at scale, so innovation is critical. Enter the AT220, a self-resetting trap with AI and facial recognition that distinguishes pests from protected species. If a rat or stoat approaches, snap. The trap triggers. If it's a possum or bird, it stays inert and safe. Another design resets automatically after each strike, and even powers down during daylight to avoid catching diurnal birds. These innovators tested traps inside Kea parrot enclosures and recorded 0 accidental triggers after thousands of images, providing strong evidence for safety. Now, the same smart traps are catching rats and mongooses in Hawaii, Mauritius, and the Dominican Republic. Even tree snakes in Guam. Kiwi Pest Tech is becoming an export industry. If other countries invest, improvements will accelerate and costs fall for everyone. AI isn't just hunting mammals. Canadian scientists use drones and machine learning to spot floating rosettes of European water chestnut. The project won a National Innovation Award and now adapts its model to track invasive water soldier and other aquatic plants. Meanwhile, in Europe, the Mambo program uses AI from a plant ID app to scan roadside photos for alien weeds. Early tests show the model can pick out target plants even with minimal training data, raising hopes for automated weed patrols. Other researchers are classifying invasive insects from images and using acoustic sensors to identify marine invaders by sound. The big picture: AI processes streams of sensor data far faster than people, spotting early signs of invasion or survivors. Smarter traps also mean precision. Each trigger spares non-target species and saves limited resources, aligning ethics with efficiency. Yet technology alone isn't a silver bullet. Local knowledge, funding, and human dedication remain essential, especially as climates shift. When you hear we've killed thousands of stoats, your heart might ache. I'm torn too. Those sleek little hunters are just following instincts, not villains. Yet we also love the curlews, terns, and voles that would vanish without action. It's like choosing between saving one neighbor or losing an entire village's song. We talk about this around the studio all the time, weighing empathy against ecology and glancing at our error bars. You've said before, you don't enjoy being the executioner, tapping your collar as you cite the data. Yet those curves make a compelling case. Does culling 100 stoats to save hundreds of chicks pass your ethical smell test? Share your reasoning in the comments and link any evidence you find so the pack can learn together.
There are also broader questions. If we accept lethal control for stoats, what about rats, feral cats, cane toads, or pythons? Where do we draw the line between compassion and pragmatism? Some people propose contraceptive vaccines or relocation, but those options have trade-offs. Animals released far away often return, and oral contraceptives like the gray squirrel trial show promise, yet scaling up is costly and slow. Gene drives could crash populations without a single shot, but the thought of engineering wild genomes makes many of you, and frankly me, uneasy. My heart wrestles with these ideas. I love these animals, yet I love the birds they threaten more. We need your perspectives. Would you support gene editing to protect native birds? Does the idea thrill you or scare you? Pause, take a breath, and tell us how you'd balance compassion, effectiveness, and risk in your own backyard.
At the end of the day, both of us agree on one thing: doing nothing is worse. If we stand by, invasive species will silently erase songs and colors we've cherished for centuries. I became a scientist because I love those melodies, and I refuse to watch them fade. We want to preserve wonder for our children, and sometimes that means making uncomfortable choices. But we also commit to transparency. We will show you our sources, invite debate, and adjust our approach as new evidence emerges. As your analysts, we'll close this chapter with a hopeful note. Technology, ethics, and people can align when we listen carefully and check our biases. Now, it's your turn. How would you design a program that's both humane and effective? Imagine budgets, monitoring, and community outreach. Drop your dream solution. No idea is too wild. And tag a friend who loves nature as much as you do.
Before we hand things back, let's pivot to real-world examples beyond Orkney. The ethical tension we've explored isn't hypothetical. It's playing out in New Zealand, Hawaii, Canada, and across Europe right now. We'll meet innovators building smart traps with facial recognition, drones spotting weeds, and citizen scientists who spotted a single hornet that saved a city from invasion. Keep your questions ready and stay curious, because these case studies show how different cultures and communities tackle the same problem in creative ways. We'll also revisit a comment from one of you who asked if smart traps could be adapted for backyard raccoons. Hint, yes, with permits. And we can't forget the pun of the week. Why did the stoat bring a ladder? To reach new heights of mischief. On that note, let's dive into the case studies. In New Zealand, an island nation with incomparable endemic birds, the goal is nothing less than a predator-free country by mid-century. That audacious target demands tools we haven't invented yet, but Kiwi ingenuity is already delivering glimpses. One standout is the AT220 trap, engineered by a company called Critter Solutions, that pairs a self-resetting mechanism with AI-driven species recognition. When a rat, stoat, or possum peeks in, the camera and microprocessor make a split-second decision. If the visitor matches the training data of a pest, a humane but lethal action is triggered. If it identifies a protected creature, like a native possum in Australia or a curious bird, the trap simply does nothing. It resets and waits, even shutting down during daylight to avoid daytime birds. This means devices can be left in the field without constant human check-ins. Engineers even tested their prototypes in Kea parrot enclosures to confirm zero false triggers across thousands of interactions, an eyebrow-raising success. Such precision is revolutionary. It conserves bait, reduces bycatch, and builds public confidence that control methods are selective. Imagine scaling that out across an archipelago. The cumulative impact could be transformative. Already, hundreds of these traps are catching rats and mongooses in Hawaii, Mauritius, and the Dominican Republic, and they've been adapted for tree snakes in Guam. New Zealand sees the technology as an export industry. The more countries invest, the faster innovation will accelerate. Elsewhere, researchers are adapting AI for very different invaders, plants. On Canadian lakes choked by European water chestnut, teams at Ducks Unlimited partnered with a software company to train algorithms that recognize floating rosettes from the air. They fly drones over lakes and rivers, then feed the footage into a model that highlights the distinctive star-shaped leaves among other vegetation. The results were so accurate, the project won a National Innovation Award and is now being extended to other aquatic weeds, like water soldier. In Europe, the MAMBO initiative borrows a plant identification algorithm from a citizen science app and repurposes it to scan roadside photographs for alien weeds. Early tests showed the AI could pick out target species even with minimal training data, hinting at a future where highways are patrolled by algorithms that raise the alarm when a new invader takes root. There are even experiments in classifying insects from photographs and using underwater microphones to recognize marine intruders by the sounds they make. Each of these cases illustrates how flexible AI can be. The same pattern recognition tools that identify stoats can also find plants or polyps if you give them the right cues. The European project uses models originally trained on PlantNet, a smartphone app. By scanning thousands of roadside images, it flags alien plants for removal. The third case study isn't a fancy gadget, but people. Citizen science harnessed by AI. In Orkney, neighbors who spot a stoat can log it on an interactive map, directing rangers exactly where to set traps. Similar networks exist around the world. In North America, volunteers using simple apps like iNaturalist or EDDMapS have flagged sightings of invasive Asian hornets, giving authorities days to destroy nests before they spread. Many regions run spotter programs for carp, lanternflies, or even tree snakes. When someone photographs an unfamiliar bug or weed, the app's AI suggests an identification, and researchers can verify it quickly. That partnership of human curiosity and machine pattern recognition is incredibly powerful. Some volunteers pull invasive plants in parks or check boats for zebra mussels. Others clean their boots between hikes to avoid moving seeds. Each action may feel small, but they add up. We love hearing your own stories about wildlife rescue or garden patrols in the comments. Those anecdotes inspire others. Think about what invasive species might lurk in your area and how you could be the hero who spots them first. Who knows? You might end up saving a forest. Early detection saves thousands of dollars in control costs. Reporting a single nest can prevent millions in damage. Many parks host annual weed pulling days, and free apps like Seek by iNaturalist help novices identify invaders and connect with experts. First, we want to celebrate our pack. Last week, one of you, shout out to Maya from Portland, shared a story about rescuing a baby raccoon stuck in your attic, then relocating it with the help of a licensed rehabilitator. That sparked hundreds of heartfelt replies, and even a pun. Raccoon, you believe it? We read every comment, and our hearts grew 3 sizes. Your stories of compassion keep us going during late-night edits and early morning research calls. Our channel recently hit a new subscriber milestone, and we could not have done that without you liking, sharing, and inviting friends. If you have a pun about stoats, raccoons, or hedgehogs, drop it below. We might feature it in our next Pun of the Week. Your kindness reminds us why we call you the Pack, a community that cares for critters and each other. Thanks for howling along with us.
We also want to acknowledge the flood of field notes you've sent. Some of you uploaded photos of tracks you found on muddy trails. We loved the Tasmanian tiger paw prints one user sent, even though Axiom raised an eyebrow and noted the extra toes suggested a dog. That gentle skepticism is healthy. Always double check before sounding the alarm. Our community map of observations has grown into a beautiful mosaic of curiosity. If you're contributing, please include your location and a brief description so we can verify and compile data ethically. And if you're uncertain, ask in the comments. We have wildlife experts lurking who love to help identify mysterious footprints. Every dot on that map helps rangers focus their search and protects animals from harm. When you take a picture, try to include a coin or your shoe for scale. That detail helps Axiom verify your find. Together, we're building a crowdsourced database that may someday aid researchers globally.
Finally, let's talk about how each of you can be part of the solution. You don't need a drone or AI model. Start by learning which invasive species threaten your area. Your state's Invasive Species Council or local environmental agency is a great place to begin. Join a spotter program, volunteer to pull weeds in a local park, or just clean your boots between hikes to prevent seeds from hitching a ride. Never release unwanted pets into the wild. And share these tips with friends and family. Awareness spreads like wildfire, but so does compassion. If you already participate in a citizen science project, tell us what you do and inspire others to join. Record what you find, note the date and habitat, and send a quick picture. That small habit could help scientists track an outbreak and act quickly.
Looking ahead, AI tools will only get smarter. We can imagine fleets of autonomous drones patrolling forests, their cameras and microphones tuned to spot pests and listen for invasive beetles before they spread. In marine reserves, underwater gliders could track alien fish by the sounds they make. These visions sound like science fiction, yet research prototypes already exist. But here's a reality check. We must decide how far we're willing to go in altering ecosystems. There will be trade-offs between innovation, caution, and personal responsibility we all must shoulder. Non-lethal methods will also mature. Researchers working on oral contraceptives for gray squirrels hope to humanely control populations without culling. Genetic biologists are testing gene drives in the lab, editing species to reduce their fertility. These tools could someday eliminate pests without killing them directly, but they raise profound ethical and ecological questions. Would you feel comfortable releasing an engineered organism into your local park? As citizens and viewers, we all have a voice in shaping which technologies we pursue. Public engagement will be crucial. Policymakers and communities need to discuss these tools in open forums and decide which pathways align with our values. What excites me most is the idea of connecting all these tools into networks. Imagine a dashboard where sensors, cameras, and citizen reports feed into a map, forecasting invasions weeks before they happen. Rangers could focus on hotspots, while communities take preventative measures. With global collaboration, open data, and respect for local customs, we can stay one step ahead of invaders rather than playing catch-up. Hope comes from that blend of technology and human care. Let's keep pushing for solutions that protect wildlife with compassion and creativity. Incorporating traditional ecological knowledge will make those systems even more resilient. To recap, invasive species like stoats can devastate ecosystems, but AI and community action offer hope. Traps, cameras, and citizen science, when combined thoughtfully, save curlews, terns, and voles without wasting resources. The moral choices are hard, yet doing nothing is worse. Stay curious, skeptical, and empathetic. If this exploration moved you, please like, comment, and subscribe. Share your pun of the week, and tell us how you might help tackle invasive species where you live. Your voice matters to our pack. And stay tuned for our next episode, where we decode how whales communicate using AI.